Hi there, this is Professor Eckhausen. I am going to talk today about piecewise linear functions. So we're going to define them, evaluate them, find the domain, and graph one using the domain. All right, so this is an example of a real-world piecewise function. This is tax rate. So if your income is up to $10,275 a year, your tax rate is 10%. That's right here. Ooh, that's a tiny little portion, isn't it? Then if you make between 10 and 41 or so, your tax rate is 12%. That's this little bit right here. So we're looking at income down here and tax rate over here. Okay? So that means that each one of these horizontal lines represents one of these tax rates. Okay, so in other words, from one part of the domain, and remember, this is the domain right here. That is the domain. So from one part of the domain to the next, we have this function. From the next part of the domain to the next, which is 10,000 to about 42,000, we have a function that looks like that. Okay, so that's a piecewise function. And if you'd like to see it in Desmos, you can make sure you're in text mode on this template, tap on See It in Desmos, and then tap on Open. And it will show you how to do this. So if you're going to graph each one of those, notice I have y equals 10 when x is between 0 and 10,275, and so on. And I had to adjust all of my axes so that these would all show. And you do that by going into the Tool button. So I changed my x-axis and I changed my y-axis. All right, so coming back here, you'll need to know when you go into Desmos how to change the domain and range. Okay, so a piecewise function is a function where more than one equation, I didn't leave enough room, did I? Equation is used to define the output over different pieces of the domain, different pieces. Of the domain. Okay, so a piecewise function is defined right here below. More than one function is used to define the output. Okay, so in other words, f of x equals this first equation if x is in the first domain. This other equation, formula 2, if x is in another domain, and this other equation if x is in the third domain. And you can go on and on like that if you'd like. It can have as many as it needs. Okay, so an example of that is an absolute value function. So absolute value is x when x is equal 0, and it's the opposite of x if x is less than 0. All right, so continuing on from there, let's look at evaluating a piecewise defined function. So be sure to pay attention to the domain. I put it in green there. I really want you to pay attention to that. Pay attention to the domain to determine which expression to use. Okay, so we've got here that f of x equals 2x minus 1 when x is less than 1. And it equals this other equation if x is greater than or equal to 1. Okay, so that's what we mean by pay attention to the domain. All right, so we're going to say, all right, what is f of negative 1? F of negative 1. So we need to go look for where is x, less than 1, because that is the input, right? So remember, when we look at f of negative 1, this is the input, which is x. So you need to go look where x is less than 1. X is less than 1 right there. So f of negative 1 is going to be evaluated with 2x minus 1. That's the one we're going to use. Well, x is negative 1 in this case. So 2 times negative 1 minus 1 is going to be negative 2 minus 1, which is negative 3. Okay, so that is going to be the point, negative 1, negative 3. All right, so f of 1, which one are we going to use? So you've got to go look and see which one we're going to use. Is it going to be, is 1 less than 1, or is it greater than or equal to 1? Well, then it's equal to, right? So you're going to use the second one. So in this case, we're going to use the second one. All right, so we've got, I'll use a different color because each of these is different. You've got the equation negative x plus 3. That's the one we're going to use. Okay, so that's this equation here. So we've got negative, our value for x is 1. I'm just plugging it in right there. Plus 3. So negative 1 plus 3 is 2. So we have the point here, 1, 2. And that's on the other line. All right, now the last one is f of 4. What is 4? Which domain is it in? Is it in the first domain or the second domain? Well, it is greater than 1, so we're going to use the negative x plus 3, the green one. Okay, so I guess I'm color coding these. I just decided as I'm working here. The top one is the purple one. The bottom one is the green one. And the green one is used for the second two. Okay, so you just have to pay attention. So negative 4 is our number. Plus 3. Negative 4 plus 3 is negative 1. So this point, the input is 4, the output is negative 1. So there's our point, 4, negative 1. All right, so now let's check using the graph, right? So we just had, let me rewrite these. F of negative 1 was our purple one, that was negative 3. F of 1 was 2. And f of 4 was negative 1. So let's take a moment, pause the video, and see if that is true on the graph. So let's go look. So we'll call this one point 1. F of negative 1. So negative 1 is here to the left of 0. Go down, and I get f of negative 1 lands right here. And that, sure enough, is negative 3. Be careful reading this because there's extra lines in there for 0.5. All right, the second one is f of 1 equals 2. So let's go over to 1. Let's see, we've got two choices here. Which one is it going to be? Well, the open circle means it's not there. The closed circle means it's right there. That's where it is. So it does equal 2. All right, now try, so that is 0.2 right there. Let's label 0.1 as well. Forgot to do that. There's 0.1. So 0.3, where's that? F of 4 is negative 1. F of 4 is negative 1 right here. And sure enough, that is correct. So that is 0.3. Okay, so I just checked using the graph. Now I wanted to show you also how to enter it into Desmos, and this is how we do it right here. So you're going to say f of x equals, and here's your equation. Well, I'll stick with my color scheme. Here's your equation right here. When x is less than 1, you use these curved brackets. Okay? All right. And you're going to use inequality notation. All right, so moving on. Pause the video and see what you can do with that. Okay, so hopefully you gave it a try. So we're going to have this one be purple and this one be green like before. If x is less than 0, we're going to use the first one. If x is greater than or equal to 0, we're going to use the second one. So f of 2. No, sorry, negative 2. F of negative 2 is our first one. So it's less than 0, so we're going to use the first equation, the purple one. So we've got 3x plus 5 is the one we will be using. So we've got 3 times negative 2 plus 5 is going to be negative 6 plus 5. Which is negative 1. So our point now is negative 2, negative 1. All right, next, f of 0 is greater than or equal to 0. So it's equal to 0, so we're going to use the second one. That is 3x plus 10. So we've got 3 times 0 plus 10 is 0 plus 10, which is 10. So our point is 0, 10. All right, the next one, 2, is greater than 0, so we're going to use the second equation, 3x plus 10, and that is 3 times 2 plus 10, which is 6 plus 10, which is 16. So we've got 2, 16 is our point. Now you can go to Desmos and check that on the graph of the function, and make sure your answers make sense. Okay, so I will go there so you can see it. I'm going to open that. Now you have to be in text mode to be able to do that. When you're in drawing mode, you can't get those hyperlinks to work. All right, so there's all our points, the 3 points. Notice I put an open circle just so you could see it at 0, 5, because the green one is less than, not less than or equal to. The purple one is greater than or equal to 0. Okay, so going back where we were. Move back down. Now we're going to look at something. This is a real world problem. A cell phone company uses this function below to determine the cost for gigabytes of data transfer. So if you use between 0 and 2 gigabytes, of course not equal to 0, but greater than 0 and less than 2, your cost is going to be $25. If you use greater than or equal to 2 gigabytes, your equation is going to be that one. So let me use two different colors there. So if it's greater than or equal to 2, you're going to pay 10 times the number of gigabytes plus 5. That will be your cost. So the question is, find the cost of using 1.5 gigabytes of data and the cost of using 4. So pause the video and try that. All right, so 1.5 gigabytes is going to be this one here between 0 and 2. So the cost of 1.5 gigabytes is going to be $25. Now the cost of 4 gigabytes is going to be 10g plus 5. My g is 4, so 10 times 4 plus 5. That is $45. Does that go with the graph? So find 1.5, and I'm right here, and that is still at $25. Then find 4, and that is over here, and that is at $45. Okay, so that is the graph of a piecewise function. That's what it looks like. So now people are going to be tempted when you graph these functions to put a point right here. You don't put a point in the middle. You don't put a point in the middle. Lumen will count it wrong if you're using Lumen or any online math program, because that is technically not correct to have a point in the middle. All right, so find the domain of a piecewise function. So remember, there is a different domain for every piece of the function. That's where piecewise comes from. Every piece of the function has a different domain. So this is a kind of problem you may see in the homework. You're given a graph of a function, and we are supposed to enter the domain as inequalities. Okay, so we're going to use inequalities. So usually piecewise is written with inequalities. Not always. But. All right, so f of x equals 4. Which one is that? Well, f of x, remember, f of x is y. Y equals 4. So where does y equal 4? Well, it equals 4 right here. All right, so y equals 4 there. So what is the domain? Well, it goes from -4 to -1, and it is solid, so it includes them. So we're going to say if -4 is less than or equal to x is less than or equal to -1. All right, so let's look at the next one. The next one is f of x, or y, equals 3. That's that one. And that is going to go between here, -1, and here, 3. Now, which one is open? Make sure you don't include that. So remember, when it is an open circle, it's going to be those symbols. When it's a closed dot, it's going to include the dot. So the open dot, it literally means you're not including that point. So just think of it that way. The closed dot means this point is included. All right. So we've got from -1 is less than x is less than or equal to 3. All right, and that is because at -1 it's an open dot, and at 3 it's closed. All right, you try the last one. All right, here's our -2, and it goes from 3 to 5. It does not include 3, so 3 is less than x is less than or equal to 5. All right, so question for you. What if that dot was closed in? What is the problem with that? The problem is that it does not pass the vertical line test. This thing is no longer a function because a vertical line goes through 2 points right there. So when you have a piecewise function, if it is a function, it can never have 2 dots one above the other. All right. So if I said, what is f of -1? What would you say? What is f of -1 from the graph? Well, you'd go to -1 right here, and you'd find where the actual dot is, and it would be 4. So f of -1 equals 4. All right, So let's move on to the next question. Graphing a piecewise function. So now we're, the steps are here, but so the first step is to indicate the boundaries defined by the domain. You're not going to graph those, but you just need to think about it. So I usually put it on my graph somehow. That's not going to be on your final answer. So for each piece of the domain, graph on that interval using the corresponding equation. Do not graph two functions over one interval because it would violate being a function, like I was just saying above. All right, so f of x equals -4, right? So this f of x equals -4, that is just y equals -4. And it goes from x equals -6 to x not really equal, right? Not really equal to -1. I don't really know how to say that. I'm just trying to put it into English, but I'm looking at this domain right here. All right, it's not really equal to -1, but it goes to the boundary. Okay, so from -6 to -1, but not including this one, right? We are going to have a line y equals -4. Well, what is this line right here? Well, remember that's a horizontal line. Horizontal line at y equals -4. And it goes from, let's see, where's -4? -4 is here, so it goes from here to here. All right, so from there to there. All right, so we're going to put a line in between. So there's the first portion. Okay, I'm going to erase all my mess that I made. All right, next we've got y equals 2. Y equals 2. When we're between -1 and 3, I'm going to do it the right way. So remember, this means there's going to be a closed dot here, and this means there's going to be an open dot. So at -1, there's going to be a closed dot, and at 3, there's going to be an open dot. And where is it going to be? Well, it's going to be at y equals 2 here. So I've got closed dot, open dot, and a line in between. That's the line y equals 2. Okay, last one. Do it in a bright color. It equals 5. Y equals 5. That's going to be this line here, right? But it's only going to go from x is greater than or equal to 3. Right? So when x is greater than or equal to 3. So remember, that is going to be a closed dot. Well, greater than or equal to means it's going to go on forever to the right. It's greater than. All right, so it starts, so let's see, y equals 5. That's right up here, this line here. So it starts at x is greater than or equal to 3. Okay, so this is considered a continuous. Well, there's no real breaks in it, right? There's no gaps between -4 and to infinity. Because if we get to -1, right, we choose one of them, well, we would choose this one. If we get to 3, we choose one of them, we choose that one. Okay, so I'm going to erase that because I don't want you to look back at it and think you need to write it down. All right. Okay, so that's how you graph a piecewise function. All right, now here's a different kind. Notice that the middle one is not just a horizontal line, so we're going to have to think about that one. So let's do the two other parts first. So we've got y equals, or f of x equals -6 when x is less than 1. So it equals -6. So -6 is here, right there. And it's going to be from x is less than 1. 1 is here. So there's an open circle. Oop, not 5, 6, sorry. 6. All right, so there's an open circle at 1, and it's going to go all the way to the left, right? That means all the way to infinity. Remember, so if we did interval notation, we would say -infinity to 1, not including 1. All right, so then I'm going to jump down to the last one, y equals 2, when x is greater than or equal to 5. So that's going to be a closed circle. This one up here was an open circle. So greater than or equal to 5 means we're going to start here. There's our boundary. And we're going to go to the right. Okay, so, and that is at y equals 2. So that's right here. So closed dot, lots to think about, and off to the right. So many things to think about. I think I got it. All right, so the last one is going to be this one here. So that is y equals x. Well, what does that look like? Well, that looks like, 1, 1, 2, 2, 3, 3. It's this line here that goes directly horizontal. directly diagonal. But it only goes from here to here. It goes from 1 to 5. Okay, 1 is less than or equal to x is less than 5. In other words, it goes from 1 to 5 like that. So this one is going to be a closed dot and this one is going to be open. But where do you start? Well, at 1, it needs to start at 1. So 1, 1, right? 1, 1. And then we go to, and that's a closed dot, and then we go to 2, 2, 3, 3, 4, 4, and then when we get to 5, this end right here, so this end is 1, 1, this end is 5, 5, but it's an open dot, so 5, 5 is here. Now we have to just fill in between, straight line, and that's how you do it. Okay, so you just find what the line looks like in the space. And you won't have any much harder lines in this class than just x or maybe 2x or something like that. All right, let's look at a couple more examples. This is a real life situation. We're just going to look at this one. An online comic book retailer charges shipping costs according to the following formula, where n is the number of comic books. N is the number of comic books that a person buys. So if they buy between 1 and 14, 1 to 14, this is the shipping cost. If they buy 15 or more, they don't have to pay shipping. It's free. All right, so this line must then start at 1 because anything less than that doesn't make sense. You don't buy zero, you don't buy 0 comic books. And then up to 14. So this thing goes from 1 up to 14. Well, then how are you going to say S of n equals 0? At 15 or more? Well, that line would be from here on forever. So here we should have a dot at the end and a closed dot at the end. And then the last line would be what I drew at the bottom. Maybe a little straighter than that, but like that. All right, so that means if I bought 10 comic books, my cost would be right here around $17.50. If I bought 5 comic books, my shipping would be $10. So if I bought 15 or 16 or 17, I wouldn't have to pay any shipping. So that's a piecewise function in the real world. All right, so I'm going to erase some of those. Okay. Identify the domain and range of a continuous piecewise function. We've done some things like this, but this is what it looks like for a continuous piecewise function. Notice there's no breaks. Continuous means you don't pick up your pencil. You would just draw, 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 and you would never pick up your pencil. Okay? So the domain of this is going to go from the very left to the very right, and the range from the very bottom to the top. So pause the video and see if you can get the domain and range correct. Okay, so the domain goes from -5 to 5. And it includes them because it has a solid dot at the end. So -5 to 5. The range goes from 1, our bottom point here, up to 5, our top point, and everything in between. All right, so the range goes from 1 to 5, including 1 and 5. All right, last problem. Try this one. All right, so the domain goes from -5 all the way over to 1. So there's our domain, -5 up to 1. Okay, so remember, in domain, you just look at the x values. The range, you look at the y values. So it's going to go from -5 up to 2 and everything in between. So we go from -5, remember to go from the bottom to the top, smallest to biggest, and it does include both ends. All right, that is all I have. Thank you for watching.